Hi, Assalamualaikum and good day. Today we are going to learn on how to determine slope and equation of tangent line and how to solve problem involving total differentials. These are the objectives of our lesson. Hopefully, by the end of this session, you are able to 1. Find the slope and equation of tangent line for functions of two independent variables, and 2. Solve problems involving total differentials. This is the relationship between dy over dx, delta f over delta x, and delta f over delta y. Dy over dx can be represented as negative of delta f over delta x over delta f over delta y, or in the short form, negative fx over fy. Refer to example 4. You need to find fx and fy using partial differentiation and dy over dx using implicit differentiation. Hence, you need to show that dy over dx is equal to negative fx over fy. To determine the fx, you need to differentiate the given function with respect to x. Here, we need to take y as constant. Differentiate x squared y, the answer is 2xy. Differentiate 2y is 0. Differentiate 3xy cubed is 3y cubed. And differentiate negative 5x is negative 5. Therefore, the answer for fx is 2xy plus 3y cubed minus 5. To determine the fy, you need to differentiate the function with respect to y. Here, we need to take x as constant. Differentiate x squared y, the answer is x squared. Differentiate 2y is 2. Differentiate 3xy cubed is 9xy squared. And differentiate negative 5x is 0. Therefore, the answer for fy is x squared plus 2 plus 9xy squared. To find dy over dx using implicit differentiation, you need to differentiate both sides with respect to x, meaning you need to differentiate each term with respect to x. Differentiate x squared y with respect to x. Using product rule, the answer is 2xy plus x squared dy over dx. Differentiate 2y with respect to x, the answer is 2 dy over dx. Differentiate 3xy cubed with respect to x. Using product rule, the answer is 3y cubed plus 9xy squared dy over dx. And differentiate 5x with respect to x, the answer is 5. Move all dy over dx terms to the left and all other terms to the right. Factorize dy over dx and simplify. You should get the following answer. The process here is what we call as implicit differentiation, which you have learned under MAT 183. When you factorize the negative to the above function, you will notice that the answer for dy over dx is actually equal to negative fx over fy. Dy over dx is referred to the slope of a tangent line. So, to determine the slope of a tangent line, you need to apply the formula dy over dx equal to negative fx over fy. To determine equation of tangent line at point x1, y1, it is defined by the following formula, which is y minus y1 equal to dy over dx multiplied with x minus x1. Refer to example 7. You need to find dy over dx for the given function using partial differentiation. To solve, you need to define fxy first, that is by moving all the term to one side. Normally, we bring all the term to the left-hand side. Next, determine the fx and the fy. For this function, fx is equal to 3x squared minus 6y, and fy is equal to 9y squared minus 6x. Substitute this into the formula of dy over dx equal to negative fx over fy. You should get the following answers. To avoid careless mistake, please put a bracket after the negative sign. Let's proceed with example 8. You need to obtain the equation of the tangent line to the given graph at point 2, 1. To solve, you need to define the fxy first by putting all the term to one side. Here, fxy is defined by x squared minus 2xy plus y squared minus 1. Next, determine the fx and the fy. Substitute the answer into the formula of dy over dx and simplify. You should get the following. As given the point 2, 1, substitute into the answer of dy over dx, you should get 1. This is referred to the slope of tangent. To find the equation of tangent line at point 2, 1, you need to apply the formula of y minus y1 equal to dy over dx multiplied with x minus x1. Substitute the point 2, 1 and also dy over dx equal to 1 into this formula and simplify. You should get y equal to x minus 1 as the equation of the tangent line. Next, we are going to learn about total differentials, which is referred to the change of the function. When given function of two independent variables, which is f, x, y, the total differential of f is given by df, which is equal to delta f over delta x multiplied with dx plus delta f over delta y multiplied with dy. Here, dx and dy are referred to the change of the respective variables. As for function of three independent variables, which is f, x, y, z, the total differential of f is given by df equal to delta f over delta x multiplied with dx plus delta f over delta y multiplied with dy plus delta f over delta z multiplied with dz. Refer to example 5. You need to find the approximate change in the volume of a cylinder for the following condition. Given that the radius, which is denoted by r, is 9 cm and the height, which is denoted by h, is 10 cm, r is increased by 0.2 cm and h is decreased by 0.3 cm, which can be represented as dr equal to 0.2 and dh equal to negative 0.3. The volume of the cylinder is given by the formula V equal to pi r squared h. Differentiate V with respect to R, the answer is 2 pi RH, and differentiate V with respect to H, the answer is pi R squared. Substitute the value of R and H into the answer and simplify. You should get delta V over delta R equal to 180 pi and delta V over delta H equal to 81 pi. Therefore, dv is equal to delta v over delta r multiplied with dr plus delta v over delta h multiplied with dh. Substitute the answer accordingly and simplify. You should get 11.75 centimeter cube as the final answer. Let's proceed with example 6. You need to use differential to approximate the expression up to 3 decimal places. First of all, you need to identify the x, the y, the change in x, and the change in y. By taking the first expression as x plus dx and the second expression as y plus dy, therefore x is given by 27, dx is 0.1, y is 16, and dy is negative 0.1. As given two expressions, the function that you need to define here is referred to function with two independent variables, which is represented by fxy equal to the cubic roots of x multiplied with the square root of y, which can also be written as x to the power of 1 over 3 multiplied with y to the power of 1 over 2. Next, determine the fx and the fy, then substitute the value of x and y into the answer and simplify. You should get 4 over 27 for the fx and 3 over 8 for the fy. Hence, df, which is equal to delta f over delta x multiplied with dx plus delta f over delta y multiplied with dy is equal to negative 0.023. This is referred to the change in f. Therefore, to estimate the value for the given expression, it is equal to f plus df. Substitute accordingly and simplify. You should get the final answer 11.977. In order to check your understanding on this lesson, please do the following questions. In the next lesson, we are going to learn on how to solve problems involving rate of change and how to determine the extremum points. Stay tuned.